Hello everyone, Namaskar, welcome to Maths Guidance and welcome to the last lecture of chapter 8, that is quadrilaterals. So today we are going to discuss the question and answer of this whole chapter, and this would be the last lecture of this chapter, and hopefully from the next lecture we'll move on to a new chapter, chapter number 9, that is area of parallelograms and triangles. So let's start the video and let's finish this chapter here. All right. So guys, let's start the video from this first question. The question is like this: in the given figure, ABCD is a square. Okay, ABCD is a square. A line segment DX, this is the line segment DX, cuts the side BC at X and the diagonal AC at O, such that angle COD equal to 105 degree and angle OXC equal to X degree. Find the value of X. Okay, let's solve this question. First of all, this is a square, so angle A equal to angle C equal to angle B equal to angle D equal to all 90 degrees. So let us write it: angle A equal to angle B equal to angle C equal to angle D equal to 90 degree. Also we know that the diagonal of a square bisects this angle, bisects the angles of a square. So diagonal AC bisects angle C. You can write here diagonals of a square bisect the angles. Okay, now from here this AC bisects angle C, that means this angle C equal to 90, so this angle 45, this angle 45. This implies angle OCD equal to angle OCX, and that is equal to 90 by 2, that means 45 degree. Okay, all right, this angle comes out 45 degree. Now applying linear pair here, angle COD plus angle COX equal to 180 degree. Also angle COD plus angle COX equal to 180 degree. This implies COD is how much? 105 plus angle COX equal to 180 degree. This implies angle COX equal to 180 minus 105, that is equal to 75 degree. All right, this angle has come out 75 degree, this angle 45 degree, so this you can easily calculate. Now in triangle OCX, angle COX plus angle COX plus angle OCX plus angle OCX plus this angle X, directly we can write X, that is equal to 180 degree. This is what? This is angle sum property of a triangle. Angle sum property of a triangle. This implies angle COX how much? 75 degree plus angle OCX how much? 45 degree plus X equal to 180. From 2 and 1 we have written this. This implies X plus 75, 580, 40, 120 equal to 180 degree. This implies X is equal to 180 degree minus 120 degree, that is equal to 60 degree. This is our answer. So X is equal to 60 degree. Okay, we are using this property. This was important here. Diagonals of a square bisect the angles. The rest is all the old things. You may be knowing all these things, angle sum property like this. Okay, so let's move on to next question. Now let's come to the second question. Second question is like this: so that the bisectors of the angles of a parallelogram enclose a rectangle. Okay, we are going to solve it, we are going to prove it. So first of all, draw a parallelogram like this. Let us draw a parallelogram like this. Let us name it A, B, C and D. bisectors of the angles. Okay, so this is the bisector of this angle. Similarly, this is the bisector of this angle. Similarly, this is the bisector of, like this, bisector of this angle and bisector of this angle. Okay, so we have to prove that this is a rectangle. Let us name it P, Q, R and S. The figure is not very good, but it's okay, we can understand it from here. Okay, so first of all, we see that in a parallelogram the opposite sides are parallel. So AB parallel to CD, AB parallel to CD, AB parallel to CD, and let us take this as transversal. AD is a transversal and AD is the transversal. Now we have studied in lines and angles that this angle A plus this angle D, angle A plus angle D is equal to 180 degree. Okay, these are the angles on the same sides of the transversal, also called co-interior angles. Co-interior angles or angles on the same side of transversal, on the same side of transversal. This we have studied in lines and angles chapter. Now let us divide it by 2 on both sides. So half of angle A plus angle D is equal to half of 180 degree. This implies half of angle A plus half of angle D is equal to 90 degree. Now half of angle A is this angle, half of angle D is this angle. So angle PAD, this implies angle PAD plus angle ADP, is equal to 90 degree. Now come in this triangle DPA or triangle ADP. Now in triangle ADP, this angle plus this angle plus this angle equal to 180 degree. Angle PAD plus angle ADP plus angle DPA, this angle DPA is equal to 180 degree. This is angle sum property. This implies this PAD plus ADP is equal to 90 from here, plus angle DPA is equal to 180 degree. This implies angle DPA is equal to 180 minus 90, that is equal to 90 degree. Now when this angle is 90, so this is the vertically opposite angle, this will also become 90 degree. So angle SPQ equal to 90 degree. Therefore angle SPQ equal to 90 degree. Vertically opposite angles, you can write here vertically opposite angles or angle vertically opposite angle. Now similarly, in this triangle, you can prove that this angle 90, this angle 90, this angle 90. Okay. Similarly, angle PQR equal to 90 degree. Angle QRS equal to 90 degree, and angle RSP equal to 90 degree. Therefore PQRS is a rectangle. Proved. All angles are 90 degree. Okay. So first of all, we are using this lines and angles theorem, that angles on the same side of a transversal are add up to 180 degree. Alright, then from this we are using this angle sum property, vertical opposite angles, and we are proving that PQRS is a rectangle. Alright, let's move on to third question. Okay, now let's solve this question, third question. In the given figure, ABCD is a parallelogram. ABCD is a parallelogram and E is the midpoint of AD. Okay. A line through D drawn parallel to EB. First of all, join EB. Then this line DL parallel to EB, and it is meeting this AB extended to F. Okay. Drawn parallel to AB meets AB produced at F and BC at L. All right. We have to prove that AF equal to 2 DC. Where is AF? AF equal to 2 DC and DF equal to 2 DL. DF equal to twice DL. Alright, let's solve it. Okay, first of all EB and DL, this is given parallel. Okay, DL is parallel to EB or EB is parallel to DL, this is given. Okay, it is given here, parallel to EB, a line through D drawn parallel to EB. Okay, so DL is parallel to EB, it is given. Now since this is a parallelogram, we can write AD is parallel to BC. Also AD is parallel to BC. This implies we can write ED is parallel to BL. ED is parallel to BL, the same thing. Now EB is parallel to DL and ED is parallel to BL. That means what? That means EBLD or DEBL is a parallelogram. Therefore DEBL is a parallelogram because both the sides are parallel. Opposite sides are parallel. So it's a parallelogram. This is the property of a parallelogram. Now this is a parallelogram. That means what? That means DE equal to BL. That means DE equal to BL. We can write the opposite sides are equal also. Also DL equal to EB and DL equal to EB. Now come to this. DE equal to BL. And what is DE? DE is half of AD. So BL equal to half of AD. And this half of AD, we can write half of BC because AD equal to BC, it's a parallelogram. That is equal to half of BC. Okay. So BL equal to half of BC. That means this is the midpoint. So BL equal to LC, we can write. This implies BL is equal to LC. We can write it. BL equal to LC. Now come to these two triangles DCL and FBL. So in triangles DCL and FBL, okay, in two triangles, first of all CL equal to BL. CL equal to BL, we have proved. This one we have proved. Also this angle equal to this angle, angle CLD and angle BLD. Angle CLD equal to angle BLF. So two things have come. Third one, you get this DC is parallel to BF because DC is parallel to AB. So DC parallel to BF, and this is a transversal. So this angle is equal to this angle. So angle LDC and LFB. All right. Angle LDC equal to angle LFB. This is called alternate angles. Okay. Since DC is parallel to AB or BF. Okay. So one side is equal to angles are equal. So through which property? This side is equal. So through AAS property. Okay. Angle side. So by AAS rule, we can say that these two triangles are congruent. By AAS rule, triangle DCL is congruent to triangle FBL, we can say. Now since these two triangles are congruent, we can write DL equal to FL. Therefore DL equal to FL and DL equal to FL, and this also DC equal to BF. DC equal to BF. Now come to this one, BF equal to DC, and DC we can write AB. We can write AB. Now BF equal to AB, that means what? These two are equal, BF equal to AB. Now what we have to prove? AF equal to 2DC. So AF equal to 2AB, that is equal to 2DC. We can directly write. This implies AF equal to 2AB, that is equal to 2DC. This one is proved. Since BF equal to AB equal to DC, so 2BF equal to 2DC and 2BF equal to AF, so AF equal to 2DC. This is proved. First one is proved. Now the second one. Second one was DF equal to 2DL. DF equal to 2DL. Okay, it's easy because we have seen that DL equal to FL. Now DL equal to FL, that means this is the midpoint of DF. So DF equal to twice of DL. We can directly write DF equal to twice of DL. So this is also proved. So it was a good question, and I hope you have got it well. Let's move on to next question. Now let's solve this question. In the given figure, ABCD and PQRC, ABCD and PQRC are rectangles, okay, where Q is the midpoint of AC. Q is the midpoint of AC. Prove that DP equal to PC, DP equal to PC, and PR equal to half of AC. Okay. First of all, this angle and this angle both are 90 degrees. We can say, because this is also a rectangle, this is also a rectangle. So angle R equal to angle B equal to 90 degree. Now these two are equal angles, so we can say that this QR is parallel to AB. QR, therefore QR is parallel to AB. Okay, we can say lines angles properties. Now QR is parallel to AB. Now come to this triangle ABC. In triangle ABC, QR is parallel to AB. QR is parallel to AB and QR is parallel to AB, and Q is the midpoint of AC, and Q is the midpoint of AC. Midpoint of AC. So by the converse of midpoint theorem, tells that this R is also the midpoint of BC. R is the midpoint of BC. Midpoint of BC. That means what? That means CR equal to BR. Now you can see similarly in this triangle also. In triangle ACD, you can do the similar things, and you will get that this P is the midpoint of DC. Okay. So DP equal to PC. Similarly, P is the midpoint of CD. P is the midpoint of CD. This implies PC equal to DP. Okay, or DP equal to CP. DP equal to CP. You can write DP equal to CP. DP equal to CP. Now come to the triangle CDB. Let us join it like this, CDB. Okay, P is the midpoint of CD, R is the midpoint of CB. That means what? That means these two are parallel lines. PR is parallel to DB. Okay, in triangle CDB, P is the midpoint of CD, R is the midpoint of CB. P is the midpoint of CD, and R is the midpoint of BC. So we can say that PR is parallel to DB. By midpoint theorem, PR is parallel to DB. Okay. Also, PR equal to half of DB. Okay, we can say also this from midpoint theorem, PR equal to half of DB. Now PR equal to half of DB, that means what? That means that is equal to half of DB. DB is equal to AC. This is the diagonals, that is equal to half of AC. We know that the diagonals of a rectangle are equal. Diagonals of a rectangle are equal. This is the property of a rectangle. Okay, so this one is proved. I think dp equal to pc we have proved here, and this one PR equal to half of AC, we have proved here. Okay, so both of these are proved. So these are the important properties you have to remember always, such that this diagonal of a rectangle are equal. Like in the rhombus, we have seen in the previous question, rhombus, yes, diagonals of a square bisect the angles. In rhombus it is perpendicular. Okay, the diagonals are perpendicular in the case of rhombus. So these are the properties you have to remember always. Okay, so let's conclude this lecture here. All right, so guys, I have solved some 4 questions and some very good questions of this chapter. Throughout the chapter I have covered all the points. So basically I want to say you that if you remember all the properties of a quadrilateral, parallelogram, rhombus, rectangle, like this, then you would not have any problem in solving the questions. Like I said that I have used so many properties, so many theorems in this problem solving. Like the diagonals of a rectangle are equal, the diagonals of a square are equal and perpendicular, the diagonals of a rhombus are perpendicular. Like one more, I said that the diagonal of a square bisect the angles of a square. Like this, you will have to remember these properties, otherwise it would be very hard to solve the problems. And these are not tough things to remember. And very soon I am going to make some shorts videos on such topic also. Already I am making some shorts videos. Please watch my shorts also, those are helpful. And please watch my videos fully. And thank you for visiting my channel and looking my videos. Okay, thank you for watching my channel. Thank you very much, and we will meet on the next new chapter number 9. All right, so please be connected with my channel. Thank you very much.